In lesson 5-1 and 5-2, we're going to talk about function operations and compositions. So the basic operations that we have on real numbers is we have addition, subtraction, multiplication, and division. And those are operations on real numbers. You can also perform those basic operations on functions. So you can perform these basic operations between functions as well. And they work exactly the same way. So if I have f plus g of x, if I see that, it just means I'm taking f of x and I'm adding g of x. If I have f minus g of x, it's just f of x minus g of x. If I have f times g of x, same thing, f of x times g of x. And if I see f divided by g of x, it's f of x divided by g of x. And a better way of writing that is to write f of x over g of x. The key prerequisite skills that you need for this lesson are you need to be able to FOIL, you need to be able to factor, and you need to be able to simplify polynomials. If you have any trouble with those things from Algebra 1, there are plenty of videos on Khan Academy if you need me to send you some. I can send you some, but you can just search for them on Google and they should pop up if you need to review those concepts. All right, so an example of doing these basic operations, we're given these 4 functions here. So f of x, g of x, h of x, and j of x. I'm going to color code them because I like to color code everything. So f of x is 6x squared plus 7x minus 5. G of x is 2x minus 1. H of x is negative 2x plus 6. And then j of x is 5x minus 7. So the first thing that we're going to do is we have a here is g minus h of x. So I'm going to rewrite what this actually means. This actually means I'm doing g of x and I'm subtracting h of x, except I want to write that in a different color. So g of x I made blue, so I'm taking g of x and I'm subtracting h of x. G of x I know is equal to 2x minus 1. So I'm going to change it with 2x minus 1. And h of x I know is negative 2x plus 6. So I'm going to change it with negative 2x plus 6. I need to make sure I put negative 2x plus 6 in parentheses since I am subtracting, because I will have to distribute that subtracting. So I'm going to distribute the minus sign to both the negative 2x and the 6, and I'm going to get 2x minus 1 plus 2x minus 6. And then when I collect my like terms, so I collect my x's, I'll have 4x. And when I collect my numbers, my constants, I will have negative 7. So g minus h of x is equal to 4x minus 7. This was just what was given to me here. And that's my answer. And then I just want to talk about what is that thing going to look like? What does that function look like? Well, if I can replace the g minus h of x with y, just like I can always do with a function. This is a function. It's just a function combining 2 other functions together. This function is going to look like y is equal to 4x minus 7, which is a line. And then I know that there aren't going to be any breaks in that line. That line is going to be infinite. So I have negative infinity to positive infinity for the domain. And then for the range, I know that I also have, it's going to go infinitely on and on, no breaks. So negative infinity to positive infinity will be the range as well. For B, I have j plus h of x. And that just means I'm taking j of x and I'm adding h of x. I know that j of x is 5x minus 7. And h of x is negative 2x plus 6. And I don't have to put parentheses around negative 2x plus 6 because I don't have a negative to distribute. I have that plus sign. So it doesn't matter if I put parentheses. If you want to, you can. But then what I'm going to do is I'm going to combine my x terms. So I have 5x and minus 2x, which is 3x. And then I have my constants combined is negative 7 plus 6, which gives me negative 1. So I know that, just bringing this down, I have j plus h of x. That function is equal to 3x minus 1. I know that function, it's like y is equal to 3x minus 1, which means I have a line, since it's y equals mx supposed to be form. The domain, again, because there are no numbers for x that I cannot plug in, it's negative infinity to positive infinity. And there are no y's that I won't have answers for, or y's that aren't shaded. So negative infinity to positive infinity as well. All right, we're going to do D first, and then we're going to go to C because it's a little harder. We have G times H of X. So what we're doing is we're taking G of X, and we're multiplying H of X. Taking G of X and multiplying H of X. Now I know G of X is 2x minus 1. And we're going to want to put both of these things in parentheses because they're expressions. So 2x minus 1, and we're multiplying by negative 2x plus 6 because h of x is negative 2x plus 6. And what I like to do when I have two expressions that I'm multiplying together, just so I make sure I'm doing it right, I like to do that little area square. And then I put these expressions on the sides to make sure that I'm multiplying every term in each expression by every term in the other one. So I have the first one, the blue one, is, I'm going to put it on the left. I have 2x minus 1. And then on the top, I have negative 2x. I'm going to separate the x term from the constant and 6. And then I'm going to make sure that what I put in the boxes is these things multiplied together, so that ensures that I'm multiplying everything that I need to be multiplying together. And then I just add all the areas at the end. So I have negative 2x times 2x will give me what's in this box, and that's negative 4x squared. I have 6 times 2x gives me 12x. Negative 2x times negative 1 is 2x, and then 6 times negative 1 is negative 6. So that's going to give me negative 4x squared plus 12x plus 2x minus 6, and then I simplify by collecting these two terms, and I have negative 4x plus 14x minus 6. All right, so that's my answer. So I'm just going to rewrite what I have up here. I have G times H of X is equal to that expression. So negative 4x squared plus 14x minus 6. And that's my answer. Now looking at that, that expression, if I have y is equal to negative 4x squared plus 14x minus 6, I know I have x to the second power, which automatically tells me that I have a parabola. So this is a parabola, not a line this time. And I know the domain is, I know that there are, when I have a parabola, is there any x value that I can't plug into this equation? No, there isn't. So it's negative infinity to positive infinity. And then my range is going to be, well, I have this negative in front tells me that I have an upside down parabola. So what this is actually going to look like is an upside down parabola on a graph. Because of that, I know the lowest value I'm going to have for the range is negative infinity, no matter what. And then the highest value, and I'm not going to calculate what it is, because we're not up to that point in Algebra 2 yet, but the highest point is going to be the vertex. So I'm going to just write the highest point is the vertex, whatever that is. We don't need to know that yet. All right, then going to C, I have f divided by g of x. So all I'm doing for that is I'm changing it to f of x divided by g of x. Okay, and so I know that I have there, I'm just going to replace f of x with, I have 6x squared plus 7x minus 5, and I'm dividing by g of x, which is 2x minus 1. So that's what I have. When you have division problems like this, there is probably going to be, when you have a polynomial on the top, there's probably going to be a way for you to cancel out the expression that's on the bottom. So you're going to need to factor that polynomial that's on the top. And the way that we factor polynomials with numbers in front of x squared that are not 1, we're going to do this off to the side. If you forget how to do this, I have 6x squared plus 7x minus 5. The first thing I'm going to do is I'm going to make that diamond. That diamond, I'm looking for two numbers that multiply to a certain number and add up to a certain number. So I'm going to make this diamond, and what I want them to multiply to is going to be a times c. This is ax squared plus bx plus c. So I want it to multiply it to a times c, and I want the two numbers to add up to b. So for this example, I want the two numbers to multiply to a times c would be 6 times negative 5, which would be negative 30. And then I want the two numbers to add to 7. And two numbers that multiply to negative 30 and add up to 7 are positive 10 and negative 3. Now, normally that would tell you the numbers that you have in factored form, but when you have a number in front of x squared that is not 1, these are going to tell you how you can break down this equation, how you can break down this 7x in the middle into two terms. So you can go to your area box or your area square and then get back to what the factored form will look like, or find your side lengths of that area square. So I have what this is going to break down into is 6x squared. This is 10x plus negative 3x. We're going to write instead of 7x. So it's going to be plus 10x minus 7x. Wait, that's not what I meant to write. Minus 3x minus 5. And then from there, I'm going to do the area square. I know this is a lot. We're going to go over this again later. The area square, and I'm going to put all of those terms in the area square where they would normally go in the opposite situation where I already had the expressions to multiply together. So I know the x squared always goes into the top left, so I'm going to put 6x squared there. I know the constant always goes in the bottom right, so negative 5. Doesn't matter where I put the 10x and the negative 3x, but I'm going to put the 10x here and the negative 3x here. Then I want to find what the side lengths are that work to get these areas. So I'm looking at 6x squared first. That's what I got to look at first. What two things multiply together? What two x terms multiply together to get 6x squared? And I could try 6x times x, but that wouldn't work if I tried to, so if I did 6x times x, that wouldn't work in making the other numbers work. I can't multiply 6x by any whole number to get 10x, so it wouldn't work. I also, if I put 6x here, I couldn't multiply anything by 6x, any whole number by 6x to get negative 3x. So what I'm going to do instead is I'm going to use 3x and 2x. And I need to conveniently put 3x and 2x, because that multiplies to 6x squared. I need to put it so that it works with the rest of my table. If I put 3x here, it won't work because there's nothing I can multiply, no whole number I can multiply 3x by to get 10x. So that means the 3x needs to go here, and the 2x needs to go here. And then I ask myself, 2x times what gives me 10x? And 2x times 5 gives me 10x. So I put a 5 there. Then I ask myself, 3x times what gives me negative 3x? And that's negative 1. So 3x times negative 1 gives me negative 3x. And then I want to check this last box. Negative 1 times 5 gives me that negative 5. So now I have my side lengths, which are actually my expressions that I'm multiplying together. If I write 6x squared plus 7x minus 5 in factored form. So instead of writing this, I'm going to write 3x plus 5 times 2x minus 1. And then I have 2x minus 1 in the bottom. Oopsies. So this is the new thing that I have, which tells me, if I look at it, it tells me, oh, that doesn't matter yet. We'll talk about that at the end. But I can cancel out the 2x minus 1 and the 2x minus 1. And then I'm left with 3x plus 5 is my final answer in simplified form. And I know that I'm just going to rewrite what I have up here. It's just f divided by g of x is equal to this. That's my final answer. And then I want to talk about what does that look like. Well, I know that's if I say y equals mx plus b form. Y equals 3x plus 5. I know that's y equals mx plus b form. So it's a line. I know the domain. See, the domain is going to be different in this case. It's not going to be like it normally is for a line because 2x minus 1, we have that in the denominator before we cancel it out. At every point in the equation, you cannot have 0 in the denominator ever. So 2x minus 1 cannot be equal to 0, which means we're going to have some restriction for what x cannot be equal to, because if it's equal to that number, 2x minus 1 in the denominator will be equal to 0. So I have 2x minus 1 cannot be equal to 0. If I solve that equation, I'm going to add 1 on both sides. That gives me 2x cannot be equal to 1, which means, is that right? Yes, it is. Divided by 2 on both sides, that means x cannot be equal to 1/2. So that's a restriction for the domain. X cannot be equal to 1/2. We're going to have a hole there. We're going to have a break for this line. So it'll look something like this on the graph. It'll look like, and then at 1/2, it's going to just stop, and then it'll continue. So there'll be a hole there, or an open circle, like that. So, what am I saying? Oh, so the domain is going to be, well, my lowest x value is going to be negative infinity. I'm taking care of the left piece and then the right piece, since there's a break. So negative infinity to 1/2. And then I'm going to do union with 1/2, which is the lowest value for the right piece, to infinity. And then the range is going to be all numbers are included. So negative infinity to positive infinity. Actually, there is going to be one thing that won't be included, and that's whatever y is. So that's wrong. Whatever y is there at that point it's also cut off. So you just have to plug in 1/2 into this equation. So I have 3 times 1/2 plus 5. So that's 3/2 plus 5, which is 10/2, which gives me 13/2. So you'd write the same thing, 13/2. And that would be your answer. Oh, God. Yeah, that's a lot. That's a lot. Don't freak out. Don't freak out. Now we're going to talk about composition of functions. Composition of functions just means collecting two functions together. So I'll be doing, for the first example, f of g of x. Or I can write it in two separate ways, so it either looks like fog of x with be careful and don't mess up that open circle with a multiplication sign, because this is not equal to f of x times g of x. What we're actually going to do is plug one function into the other. So for this first example, I have the two functions f of x and g of x, and I'm composing g of x into f of x. So I'm going to start with f of x. That's f of x is equal to x squared. But what I want to actually do is I forgot to color code these, sorry. F of x is x squared. G of x is 2x minus 1. H of x is x plus 2. And w of x is 2x squared plus 1. I think that's the same thing as it was before, yeah? No, it's not. Never mind. Okay, so f of x is equal to x squared. What I want to do is I'm going to do f of g of x. So I'm going to do f of g of x. And then what I'm actually going to do, instead of wherever I see x, I'm actually going to plug in g of x. So I'm going to take g of x and square it. Whatever g of x is, and I'm going to square it. And I know g of x is 2x minus 1. That's the expression. So instead of writing g of x, I'm going to be plugging in 2x minus 1 into f of x. So I'm going to do, everywhere I see an x, I'm plugging in 2x minus 1. So I'm actually taking 2x minus 1, and I'm raising it to the second power. And when I do that, what I like to use, again, is that area square. And I like to put my two expressions. So in this case, I have 2x minus 1 and 2x minus 1 multiplied together. And that gives me 4x squared. In the first box, negative 1 times 2x is negative 2x. I have 2x times negative 1 is negative 2x. And negative 1 times negative 1 is 1. That gives me 4x squared minus 2x plus 1, which is 4x squared minus 4x plus 1. And then I just rewrite what I have up here and write my answer as f of g of x is equal to this thing here. So 4x squared minus 4x plus 1, and this is my final answer. Okay, this is a polynomial. Sorry, this is a parabola because I have x squared. It's going to be a parabola. The domain, there's no x value I can't plug in, so it's negative infinity to positive infinity. And then the range is also the same. No, it's not. I'm so sorry. No, it's not. Because a parabola looks like this. Because it has a positive number in front of the x squared, I know it's an upward parabola, an upward u, not a downward u. So the vertex is actually going to be the lowest point, the lowest y, and it will actually be included. So it should have a bracket, just like the previous one should have had a bracket as well that I wrote this. So vertex, comma, infinity. So where's the one that I wrote? Yeah, this one here. This should be a bracket because the vertex is included. All right, so that's that. Then composing h of g of x, I am taking first h of x, which I know is equal to x plus 2. And I'm writing that out so I can see very clearly what I'm doing. What I want to put instead of x, I want to put g of x. That's what I want to plug in. So what I'm actually going to do is take whatever g of x is, and I'm going to add 2. And when I do this, I know g of x is that I'm going to just replace it with its expression, which is 2x minus 1. So the problem that I actually have, I'm plugging in 2x minus 1 into h of x. Instead of x, I'm going to put 2x minus 2 wherever 2x minus 1 wherever I see an x. And then I just simplify what I have there. So I just combine my constants, and I get 2x plus 1. And I'm just going to rewrite what I have here, or I can rewrite it like this. So I could say h of g of x is equal to 2x plus 1. And that's a line. There are no breaks in that line because there's nothing in the denominator that could possibly be equal to 0. So negative infinity to positive infinity for both the domain and the range. And then for 3, I have w of h of x, or I can write it in either one of those two ways. I'm taking w of x first. W of x is equal to 2x squared plus 1. So I know instead of x, I want to plug in h of x. So everywhere I see an x, I'm actually replacing it with h of x, whatever that expression is. And that expression is x plus 2. So that's what I'm plugging in. I'm just going to write the purple part first. So in the parentheses, I'm going to write x plus 2. That's what I want to plug in. That's what I want to raise to the second power, and then multiply by 2 and add 1. So when I do that, I'm going to end up with w, I'm not going to write that, is equal to, this is 2 times x plus 2 times x plus 2 plus 1. The first thing I have to do is multiply the x plus 2 times the x plus 2. And when I do that, I'm going to get x times x gives me x squared. X times 2 gives me 2x. I have 2 times x gives me 2x. I'm going to write that here. And then 2 times 2 gives me 4. So I have this times 2 plus 1. But you can do 2 times simplify what's inside the parentheses. So I have 2x times x squared plus 4x plus 4 plus 1. And that gives me 2x squared, because I'm distributing this, to 2x squared plus 8x plus 8 plus 1. And we just collect the constants, and then that gives us an answer of 2x squared plus 8x plus 8 plus 1 gives me 9. And then I just rewrite what I have here. So this is w of h of x is equal to that. And then I know that's a parabola since it has x squared. And the domain is negative infinity to positive infinity because there's no x value I can't plug in. This is going to be an upwards parabola. So the lowest y will be the vertex. And the vertex will be included. And then the highest y will be infinity. All right, and then just composition of functions with numbers. So that's, we're just going to evaluate what that is. So the first thing we're going to start with is what's inside. We're going to evaluate what that is and then plug it into the outside function. So we're going to start with f of x. I know that's x squared. So I'm going to do f of 3 because that's what I see here inside. And that's going to give me, I'm just plugging in wherever I see an x, I'm plugging in 3. So I'm doing 3 squared. So f of 3 is 9. f of 3 is 9, and I want to plug that into w of x, and I know w of x is 2x squared plus 1. So instead of plugging in x, I want to plug in this 9. I want to plug in 9 into that function. So I have w of 9 is equal to 2 times 9 squared plus 1. So I'm just plugging in 9 wherever I see an x. And that's going to give me 2 times 81 plus 1, which is 162, plus 1, which is 163. So I'm just going to rewrite this down here. W of f of 3 is equal to 163. Done. I don't have to say if that's a parabola or anything because it's a number. It's evaluated. And then lastly, I have f of negative 2. I'm going to start with that. So f of negative 2 is equal to, I'm going to write f of x, I know is x squared. That's the thing, that's what the function is. I'm doing f of negative 2, so that's negative 2 squared. And that gives me 4. And then I'm going to plug it into h of x. And I know h of x is x plus 2. But wherever I see an x, I want to plug in 4. So I'm going to plug in 4 into that equation. I have h of 4 is equal to, so I'm going to have 4 plus 2. Everywhere I see an x, I'm replacing it with 4. And that gives me h of 4 is equal to 6. So final answer is h of f of negative 2 is equal to 6, and I'm done.